Class 10, Chapter 6, Mathematics. The name of the chapter is Triangles. Exercise 6.1. Fill in the blanks using correct word given in brackets. Brackets means parenthesis. All circles are dash congruent or similar. They are similar. All circles are similar because all circles are in round shape. So he is telling you about congruency and similarity. Congruency means exactly equal. Similar means shape is same. Okay. All circles are similar. But one may be big, one may be small. All squares are similar. Congruent or similar means similar. Because one may be big square, another may be small square, but shape is same. Square shape. All dash triangles are similar. Triangles, take isosceles, they are not similar. Okay? The angles will change, the topmost angle. One will be like this, another will be like this. Both are isosceles, but they are not similar, right? They are not similar. But all equilateral triangles are similar. That's what we have written here. All equilateral triangles are similar. Two polygons with same number of sides are similar only when all the corresponding angles are equal or proportional. They must be equal, right? There is no question of proportionality there. So that is first page of this one. We'll just move up. Give two examples of a pair of similar figures. Okay, big slate, small slate, both are similar. Take one sharp pencil, take another long pencil, their shapes are similar. So that's what I have written here. Big slate, small slate, sharp and long pencils. Two examples I given. Non-similar figures. Oh, you can give millions of them. For example, two boys are there, their faces are not similar. We cannot, if their faces are similar, we cannot distinguish them. Who is Ram and who is Soma? Both are look alike. The face of two girls, those are the two examples. Okay. State whether the following quadrilaterals are similar or not. This one, this one. How they are similar? This is not similar to this. No, they are not similar. Let me see the answer. The two figures are not similar is the answer. Okay. Now comes similar triangles, and there is a theorem 6.1 which is very, very important. Very damn important. Theorem 6.1. If a line is drawn parallel to one side of a triangle to intersect two other sides in distinct points, the other two sides are divided in the same ratio. That is the lyric of this theorem. If a line is drawn passing through AB and AC, which cuts AB in B, AC in E, then if a line is drawn parallel to, right, here it is, a line is drawn parallel to this side, BC, so that it cuts the other two sides in D and E, then AD by DB equal to AE by EC. That's what we had to prove. So, first you should write what is given. given that DE is parallel to BC. Okay, let me remove that. Given DE is parallel to BC, we have to prove AD by DB equal to AE by EC. Now, construction. Join D is a point, E is a point, right? Join BE, join CD, and draw perpendiculars in this triangle. In this triangle, draw perpendiculars to opposite side. DM is perpendicular to AE, and EN is perpendicular to AD. This is the construction. Okay. Now you see the triangle. Now you pay your attention to the triangles ADE. This is one triangle. And DBC. This is one triangle. BEC. This is one triangle. This is one triangle. You have to take a look. Then this is one triangle. This is one triangle. This is other triangle. These are the three triangles we have to take into account for the purpose of proving this theorem. Area of the triangle ADE divided by area of the triangle BDC divided by triangle BDC. ADE by BDE. You take that ratio. And you take the ratio of ADE by this triangle. First, this triangle by this triangle. Second, this triangle, same triangle, by this triangle. Okay? They are equal because these two are equal. This one is equal to this one. Do you know why? Because their base is same, their height is same. Because both BDC and BEC are equal. Both height is same, base is same. For both the triangle, BC is the base. This is the base. And for both triangles, this is the height, distance between the two parallel lines. So we say generally, the 9th class, you have got a theorem that if two triangles are there with the same base and between two parallel lines, they are equal. Okay? You apply that theorem here. Let us go up a bit. So area of ADE is this one. Area of BDC is this one. Area of ADC is this one. Area of BEC is this one. This is equal to this. Half cancel. EN cancels EN. DM cancels out EN. What is left is AD by BD equal to AE by EC. Proved. That is how you should prove that theorem. That's a very important theorem that will come. And theorem 6.2, that is converse of 6.1. If a line divides the two sides of a triangle in the same ratio, then it is parallel to the third side. If AD by DB equal to AE by EC, given that AD by DB equal to AE by EC, then you prove that DE parallel to B. So this theorem is proved in a negative way. Okay. Suppose AD by DB equal to AE by EC, that is given, and you join DE. If this is not parallel to BC, draw a parallel here, that white line, DE dash to BC. Now BC is parallel to DE dash, right? Not DE. So DE, we are assuming DE is not parallel. So DE dash we drew. So DE dash is parallel to BC. If DE dash is parallel to BC, AD by DB must be equal to AE dash by E dash C from the above theorem. But it is not correct. Why? It is clearly given that AD by DB is AE by EC. So E and E dash are not two different points. They must coincide. DE must be parallel to BC. That is the proof of this theorem. Let us go up. Now we have some examples here. ABCD is a parallelogram with AB parallel to DC. E and F are points on non-zero parallel sides. On non-parallel sides. E and F are points on non-parallel sides. What is this? This is not there. Okay. ABCD is a parallelogram with AB perpendicular to D, parallel to DC. AB is parallel to DC. EF are points on non-parallel. These are non-parallel sides. BC and EAD are non-parallel sides, such as EF. This EF. Show that AE by ED equal to BF by FC. AE by ED equal to BF by FC. This is what we have to prove. ABCD is a parallelogram with AB parallel to DC. E and F are points on non-parallel sides, AD and BC respectively. AD మీద E, BE మీద F. Okay, that's why you say respectively. So join EF. AE by ED equal to BF by FC is what we have to prove. Let us go up. So now join AC. AC, you have two triangles. This is one triangle and this is second triangle. Right? You must be able to visualize those things. Now, because it is given, what is given there here? EF parallel to DC is given. EF EF parallel to DC. Okay. Join A and C. A and C. So you take this triangle. In this triangle, EG is parallel to DC. So AE by ED equal to AG by GC. Yeah. Understood? Similarly, take the other triangle. This AG by GC must be equal to BF by FC because BF is parallel to AB. Okay? From 1 and 2, the answer comes. Proved. This is 1. This is 2. From these two, the answer is coming. Example. In triangle given, LPST, LPRQ. In triangle given, it's not L, this is angle. Angle PST equal to angle PRQ. Angle PST is equal to angle PRQ. PS by SQ is PT by TR. This is what we have. This is also given. PS by SQ equal to PT by TR. What does that mean? If PS by SQ is equal to PT by TR, that means ST is parallel to QR. Okay? ST is parallel to QR. When these parallel to QR, these are corresponding angles. These are equal. This is equal to this is equal to this and these are equal. So PQR must be isosceles triangle because this angle equal to this angle. And opposite sides are also equal. Okay? That's how we proved this. Now we are going to exercise 6.2. In the given figure, okay, we will do this experiment exercise 6.2 later. We will close this here and we will do another video from here, exercise 6.2 onwards. This, whatever we did, covered some examples related to 6.2 and exercise 6.1 also we did in this video. Thank you for watching this video. Do not forget to subscribe.